Alright, now we're going to look at some math that accompanies our half-life problem. So when we're looking at the math for the half-life, it's very important that you follow the same steps every time. Okay, I'm going to show you a method called the box and arrow method, which involves us drawing boxes and drawing arrows. Okay, we're going to put our original amount of our sample into our first box. We're going to put our half-life over the first arrow, however long it is, and then we are going to continue doing our half-life by dividing by 2 as many half-lives as the problem asks us to do. So in our first example here, it says an element has a half-life of 4 years. This means that it'll take 4 years for the half-life, half of the sample of this element to decay. If you start with 100 grams of this element, how much will you have after 12 years? How many half-lives is this? Okay, so it's asking us two different questions. It's asking us how much we're going to have after 12 years and how many half-lives it goes through. So when we're using our box and arrow method, we're going to draw our first box. We're going to write in our amount that we start with. In this case, it is 100 grams. So I'm going to write 100 grams in our first box. Okay, so in each arrow represents our half-life. Here it says 4 years is our half-life. So for our arrow, we're going to write under it 4 years. So 4 years later, half of it has decayed. So we're going to take half of 100. So we do 100 minus 2, and we get 50 grams of our sample remaining. Okay, it says after 12 years. We've currently gone 4 years. So we're going to do another 4 years here, which gives us a total of 8 years. After 8 years, half of our 50 gram sample has decayed, so we have 25 grams remaining. Okay, 4 more years, one more half-life, after 8 years would then be 12 years, and that's what the question is asking. It says after 12 years, so we know that our answer is going to be right here. We do 25 divided by 2, and we get 12.5 grams. That is our answer for how much of this element will you have after 12 years. We are going to have 12.5 grams. How many half-lives is it? To find this, all you have to do is go back and count your arrows. We have 1 arrow, 2 arrows, and 3 arrows. So it would be 3 half-lives. So after 3 half-lives, 12 years has elapsed, and we're left with 12.5 grams of our original substance. Okay. So looking at example 2, we're going to do the same exact thing. Here I have less of it written out for you. I just have the boxes and the arrows. And we're looking at how much of a 60-gram sample of a radioactive element will be left in 4 days if it has a half-life of 2 days. So in our first box, we put how much we start with. It says 60 grams, so I'm going to write 60 grams. After our first arrow, that's 1 half-life. So it says half-life is 2 days. So our first arrow is 2 days. After half-life, all you do is take what you started with, divide it by 2. So we're going to do 60 divided by 2. That gives us 30 grams. Okay, one more half-life would be another 2 days. So 2 days and then another 2 days gives us a grand total of 4 days later. And we do 30 divided by 2, which will be 15 grams. So we are left with 15 grams of our sample after 4 days, and that's 2 half-lives. We have 2 arrows, 2 half-lives, and it's a grand total of 4 days. Okay. So these get a little bit harder, not much harder, just a little bit. The main key to these problems is you have to figure out what they're asking. Okay, so in number 1 here, how much of a 120 gram sample of polonium is left after 15 days if it has a half-life of 5 days? So we're going to do our box and arrow method. In our first box, we put what we start with. We have 120 grams. Okay, after 1 half-life, so I draw 1 arrow for 1 half-life. It says a half-life of 5 days, so I'm going to put 5 days. And we are left with half of 120 grams, so that would be 60 grams. Okay, we are going to 15 days here. Okay, so we have 5 days. We're going to do another arrow that is now 10 days. Okay, another 5 days gives us 10. And then another arrow after that would give us our 15 days. So that's what we're looking for. So after 10 days, we take half of 60. That gives us 30 grams. And after one more half-life, we do half of 30, which would give us 15 grams. Okay, so we have 15 grams after 15 days. So if you look at number 2, how much of a 60-gram sample of a radioactive element is left after 8 days if it has a half-life of 4 days? Okay, we do what we start with. We have our 60-gram sample. we have our first half-life, which would be 4 days. After 4 days, we have 30 grams. Okay, and it says left after 8 days, so we need another half-life, 4 more days. So we had 4 days, we have 4 more days, so we have a total of 8 days. That's what it's asking us about. And half of 30 would be 15 grams. Turns out that a lot of these examples have the same answer. Okay, so as you're going through, you're looking at what exactly they're asking you. Okay, what if the half-life of a substance that originally had a mass of 80 grams, but after 6 days only has a mass of 10 grams? So this is asking you something in a different way. Instead of telling you how many half-lives go and asking you how much is left at the end, instead it gives us our starting of 80 grams. Okay, and after 6 days, it has 10 grams. Okay, so we're going to have to do our math and then work backwards to find what the half-life is. So we start with 80 grams. 1 half-life later, we have 40 grams. 1 half-life after that, we have 20 grams. And then another half-life would give us 10 grams. Okay, so we started with 80. We now have 10. We have to go back, and grand total is 6 days. So we have to figure out how many half-lives took place over 6 days. So remember, each half-life is the same amount of time. So after 3 half-lives, we've reached 6 days. So there's a mathematical way to do this. You can take the grand total of your days divided by your number of half-lives, and that gives you how long each half-life is. So 6 days, 3 half-lives, 6 divided by 3 means each half-life is 2 days. So the first one was 2 days, the second one is 2 more days, which is 4 days later, and then 2 days after 4 days would give us 6 days. So it's asking you the same question, it's the same type of problem, it's just working it in a different direction. So you have to make sure you know what the question is asking you before you go through and work it. So the last example we're going to look at is number 4 here. How much of an 80-gram sample of uranium-238 is left after 40 days if it has a half-life of 10 days? So we're going to write out what we start with, 80 grams. After 1 half-life, which is 10 days, we have half of 80, so we have 40. We're going to have another half-life, 10 more days, so a total of 20 days. We take half of 40 grams, so we have 20 grams. We have another half-life, which is 30 days. And it gives us half of 20, so 10 grams. And it says left after 40 days, so we need one more half-life, so I'm going to come all the way around because I ran out of space on my paper. So one more, half of 10 would be 5 grams, and it will be a total of 40 days later. So we went through 1, 2, 3, 4 half-lives. It gave us 40 days total, and we have 5 grams of our sample of uranium left. So make sure you work through the rest of your practice problems. There is a key listed under this video for you to check your work. So make sure you work through it, check your work, and make sure you understand what's going on.